Hi. Last time I had promised you that I was going to derive the relativistic redshift formula from what I said last time in the other video, the one on relativistic redshift and gravitational redshift and cosmological. Basically, the idea in the special relativistic redshift is this: you have one observer here, and then another one here. This guy is sending signals like that, right? Like that, like that, like that to the other guy. Signals meaning, for example, this could be a photon. So this is the world line of a photon. This is the world line of a photon, the world line of a photon, and he's emitting them at regular intervals. So the time between here and here is this time t. The time between here and here is also t, etc. Right? And then the other guy is going to receive these at time t prime. You know, it happens that in this case the situation is everything is regular. So if this guy emits at time t, this guy's going to get them all at the same time interval t prime. So the time between here and here is t prime, the time between here and here is t prime, the time between here and here is t prime. Now it turns out that since t and t prime are just, you know, two numbers, right, then one can be written as a constant, as a factor times the other. So t prime will be some kind of factor times t, okay, and that factor will be the redshift factor. Okay. Now one thing that last time I mentioned, basically, that this can be sort of broken down really as to what happens here, right at this crossing, okay, or even on this side. By the way, if the guy keeps going and now he sends signals this way, right, it turns out that now, you know, he's still going to be emitting them at time capital T, right? This, the time between here and here is still capital T, but now after he crossed the t prime here is going to be different than the t prime down here. That's just like, you know, when an ambulance passes you by, right? As it's coming towards you, the frequency seems higher, but then, you know, when as it's moving away, the frequency of signals that it sends to you seems lower. Because notice that this guy's always sending the signals into the future, and the other guy's getting them. And here's the same thing: after he passes him, sending the signals into the future. So I said that all this can be basically captured by looking at this just little piece right here that I put in this circle right here, right, magnified, and it's this. Okay, so this is the t prime, the t, and the l. And I said, hey, if you're able to, you know, figure out what's the relation between t prime, t, and l, right, or rather really between t prime and t. The l's they're just to, you know, to help the calculation along, right? If you figure that, you're good. You got what the redshift is. You can figure out the redshift factor. So how are we going to approach this? I said there were many ways to do this, right? Something, you know, drawing xt diagrams and blah blah, or just with abstract vector methods. So I'll do, you know, like a slight half-breed, and the reason is because this one I think is the best one for stuff that comes afterwards. So here it is. You go and you fix a basis of vectors e, lowercase e, small e, and capital E. Okay, that's going to be an orthonormal Lorentz vector, meaning that a little e is time-like, so little e squared is -1. A capital E is space-like, so capital E squared is 1. And then this would be another basis, and it turns out that if we pick the speed of light to be equal to 1, so c equals 1, then the picture is very symmetric, right? So we have this other basis, e prime, little e prime, and capital E prime, and that basis is also orthonormal. So in other words, little e prime squared is -1, a capital E prime squared is 1, and little e prime dot capital E prime is 0. That's here, right? Squared 1, and then little e dot e, and also little e prime dot e prime is 0. So they're both orthonormal frames. Now this little e represents one observer, right? So that could represent this vertical guy here. Okay? And the little e prime is this other guy. Okay? So, and now turns out that little e prime from this here is a linear combination, right, of little e and e. So in other words, I can express the vector little e prime in the basis little e capital E. Little e prime equals this. By the way, it turns out that since this A is the time part and this B is the space part, it turns out that B over A is the velocity of E prime as seen by E, you know. But we'll talk about that a little bit more later. Okay, and look at this. Note then that minus A squared plus B squared equals -1. Why is that? Because look at this equation right here.